We'll go ahead and get started. Hello everybody, my name is Thomas Cameron. I am a Senior Principal Technical Marketing Manager at Red Hat. Been with the company for about 12 years. I am a Red Hat certified architect, so I am a technical resource in the marketing group. I'm one of the folks who helps architect how we talk about cross-portfolio technologies. So I'm a big old nerd. I've been with the company for 12 years. Before that I was a Microsoft guy, and before that I was a Novell guy, so that kind of dates me right there. I was a NetWare certified engineer, so been doing this for quite a long time. We are going to be talking about security enhanced Linux for mere mortals. So let's talk about what we're going to talk about today. I'm going to talk a little bit about Red Hat's involvement in security enhanced Linux. I'm going to talk about what SELinux is, where it came from, and some of the core concepts of security enhanced Linux, like mandatory access control versus discretionary access control. I'll talk about how SELinux works. Most importantly, we'll talk about type enforcement and labeling. I'll talk about how to deal with labels, and we'll go through some real-world examples that are based on things that I have done or customers have done where SELinux got in the way and it was difficult to try to figure out how to get through it. So my contact information is up here. I'm real easy to reach. I am thomas@redhat.com. I've been here for that long. I am Thomas D. Cameron on Twitter, and you can also follow me on Facebook at facebook.com/redhatthomas. And I'm also on Freenode on IRC. My nick is Choirboy. And this deck and a bunch of other decks that I've done are available at people.redhat.com/tcameron. You will also get this deck. It'll be published on the Summit website. So a lot of times I'll see people trying to take pictures of the slides. You're welcome to do that, but you'll get the deck in PDF format later on. So you should be fine there. So a little bit about where SELinux came from, and specifically what Red Hat has been doing around SELinux. We are definitely the leader in development of security enhanced Linux. John Dennis, Ulrich Drepper, Steve Grubb, Eric Paris, Roland McGrath, James Morris, and of course Dan Walsh are all Red Hat staffers, and they have been called out by the NSA for their participation in the development of security enhanced Linux, and Red Hat has also been acknowledged as a leading corporate contributor with the National Security Agency as well. So where did SELinux come from? It was originally developed by the NSA as a series of patches to the Linux kernel using Linux security modules. Kind of an older technology. It was back in 2003 that it was approved in upstream, but it was actually released to the open source community in 2000. So this is a very mature technology that's been around for a very, very long time and is literally battle tested and battle hardened. Now, I'll be real honest with you. The reason that I did this presentation many, many years ago is because if you guys remember, now I'm dating myself, the old comic books that had the 98-pound weakling that the big guy kicked the sand in his face on the beach, that's how I felt about SELinux. Before I came to Red Hat about 12 years ago, I was an architect on the Linux engineering team at Bank of America, and I was responsible for the rollout of RHEL 4 and specifically around security enhanced Linux. Anyone deal with SELinux back in the RHEL 4 timeframe? I'm so sorry. Because it was brutal. We didn't have the tools that we have today, and we didn't have the logic built into it today. And it was hard. It was really, really hard. And unfortunately, SELinux got a really bad reputation at the time. So if you feel the same way, if you feel like SELinux is this big brute that's kicking sand in your face, you're definitely in the right place. We're going to talk through it, and by the end of this, hopefully, you'll be real comfortable with SELinux. So some of the concepts that we need to understand are discretionary access control versus mandatory access control. Now, traditional Unix systems have always used discretionary access control. So you have the concept of owners of files and processes, right? The user that owns the file, the group that owns the file, or anyone else, which we call other, plus permissions. You can have read, write, execute permissions on the files, and you own them. And users have the ability or discretion really to do whatever they want to with their files, right? A user can chmod plus RWX on their home directory, and there is nothing that's going to stop them. Nothing's going to prevent other users or processes from getting into that home directory and doing mayhem. And in traditional Unix mentality, we will absolutely hand you the pistol and show you where your foot is. But that's kind of how Unix and Linux are, and that's fine. We want to have flexibility. And historically, Linux and Unix systems have had discretionary access control, where the root user is omnipotent. If I have root access to the machine, there's nothing you can do to stop me from getting to your stuff on traditional discretionary access control systems. On a mandatory access control system, though, there is a policy which is administratively set and fixed. Even if you change the discretionary access control on a directory or on a process, if there's a policy in place with a mandatory access control system and another user tries to access it, it is generally going to stop it. Now, just like every other piece of software in the world, every once in a while there's bugs. And that's, you know, we as soon as we find out about them, we will fix them. If you find a bug in the policy, please let us know. But for the most part, and in the overwhelmingly vast majority of cases, SELinux works amazingly well to keep bad guys from getting to sensitive parts of your system. And these policies can be insanely fine-grained. You can figure out, or you can make changes with SELinux to limit access between users and files and directories and processes and memory addresses and TCP or UDP or sockets. All kinds of things can be managed by SELinux, or can be protected by SELinux, I should say. Now, in SELinux, we have the concept of the policy. There are a number of ways that you can configure SELinux to protect your system. The most common that you're probably going to see with the Red Hat Enterprise Linux or derivative system like Fedora or CentOS or Scientific Linux or whatever, most often what you're going to see is the targeted policy. And the targeted policy says we're not going to do anything except for those processes or services that we have a policy for. Now, having said that, there are hundreds and hundreds of policies that are protected by SELinux. To give you an idea, you know, you would expect that there would be security policies protecting, say, network-facing services like the web server or the mail server or whatever, and those are all certainly in place. But we even have SELinux policy around things like your web browser and your email client and things like that. So the targeted policy is actually incredibly comprehensive, and those processes or tasks or services that are managed by it, or I should say protected by SELinux, are good. Everything else is unconfined. Now, the other one that you will likely see is MLS, or multi-level security. This is multi-level and multi-category security. It is out of scope for today's session. We've only got 45 minutes, and it's a fairly complex topic. It can be really, really complicated, and typically you only see it in government entities like the Department of Defense and military and things like that. So you can determine what policy your system is set to use by looking at the file etc SELinux config, which is also symbolically linked to etc sysconfig Linux. You can run the se status command, or you can run get enforce. So if you look at that file, you can see right about a third of the way down it says SELinux equals enforcing. So that tells you what the policy is for boot time. You can also run se status, which will give you some information about what's going on with SELinux and also whether or not it's enabled. And if you just need to know quickly, yes, no, is SELinux turned on, you just run get enforce and it'll come back as either enforcing, permissive, or disabled. So how does SELinux work then? Well, there are two concepts that you really need to understand with SELinux. There's a ton of other stuff that's available, but there are really two concepts that you need to understand, and that is the concept of labeling and type enforcement. And let's look at those a little bit more deeply. Labeling are all given an SELinux, or I'm sorry, all the files and processes, ports, and so on have an SELinux label associated with them. For files and directories, that label is actually stored as an extended attribute on the file system, depending on the type of file system that you have. And for processes and ports and network interfaces and things like that, the kernel manages those. As the kernel boots up and the file system loads and processes run, the kernel will manage all of those and keep them in memory, all the labels. The labels are in the format of the SELinux user, the SELinux role, the SELinux type, and optionally the level, so multi-level and multi-category security. For the purpose of this presentation, we don't really care about the SELinux user or the role or even the level. Those are used in more advanced implementations of SELinux, so we're not going to talk about those today. But what we really care about is the label. Because remember, two key concepts, labeling and type enforcement. So I'm going to use a fairly complex service as an example. This service provides access to pretty much your entire file system, depending on how it's configured, and it listens on the network, and so it can potentially be a source of security risk, although I do want to make clear, I'm not up here saying that Apache is insecure. It's not. It's pretty doggone secure. But it does, because of its ability to access the entire file system, it makes a great example for talking about SELinux. So starting from the executable, the file that's on the disk that we use to launch it, the Apache HTTPD binary, it runs from under user sbin, and if you look at that file's SELinux context on disk, you'll see that the context is httpd_exec_t. So you can see where when I did the ls-lz and I got a much wider output than what you're used to seeing when you do an ls-l. What we care about is where it says httpd exec-t. That is the type that is stored as extended attributes on the file system. And I forgot to fire up my pointer, so you can't do a demonstration, can't do a presentation without a pointer. All right, so you've got the httpd exec type as the label. Now, if I look at the server's configuration directory, if I do an ls-z against etc httpd, you can see that again, it's httpd config type. And if I look at the log file directory, httpd_log type. And if I look at the content, where we store content that the web server is going to be able to read, httpd system content type. And even the startup script has an SELinux label, httpd and unit file type. And so you can see that there's all of these executables, all of the directories, everything that's associated with the web server has an SELinux label. When I run the process and it's running in memory, if I use ps-Z, I'll see that it even has an SELinux context while it's running in memory, so httpd type. If you look at the ports upon which the web server listens, you'll see that those are labeled as well. And I'm going to use a slightly different command here. I'm going to use netstat. But if I do netstat and I grep out httpd, once again, you can see that it's listening on 80 and 443, but it has that SELinux label. And if I use the semanage command to list all of the port labels, you can see that everything that's associated with HTTP port type is going to be attached to those port numbers. That'll be important in a little while. Now, changing gears a little bit, the etc shadow file, that's shadow_t, or it has the shadow type label. SELinux uses type enforcement. We've learned all the types, all the labels, right? All of the types for these executables and processes and directories and files. So it probably makes sense for a process running in the HTTPD type context to interact with a file in the HTTPD config type label, right? I mean, that kind of makes sense. But do you think it makes sense for a process running with HTTPD type to access a file that's got the context shadow type? Do you want your web server to serve up your shadow file? Raise your hand if you think that's a good idea. No volunteers? All right, good, because we were going to laugh at you. All right, so that's in a nutshell how type enforcement works. It says there's a policy defined on the system, the SELinux policy, that says a process running with the label HTTPD type can have read access to a label filed HTTPD config type. So it's saying it can do this, and if it tries to do something else, like if a bad guy compromises your web server and they take control of that executable that's running in memory and they say, ha ha ha, I'm going to get the passwords, and they point it over at the shadow file, even if that shadow file is somebody did something silly like did chmod 777 on it, SELinux is still going to stop them. So SELinux is sort of a belt and suspenders approach to security, right? We've got all the discretionary access control settings correct, but we also have mandatory access control. So you've seen me show you a whole bunch of different labels. How do I deal with these labels? Where do they come from and what do I do with them? You saw me use the -Z argument to a number of commands. -Z is pretty much universally the argument that you're going to pass to any of the commands on a Linux system that can give you additional information about SELinux. So I can do ls-z, I can do id-z ps or netstat, cp or makedir. I can actually set an SELinux context when I create or copy content. You can also use SELinux aware tools like chcon, change context, or restorecon, restore context, to change the context of a file. And I'll show you some examples of that in a little while. These contexts are set when files are created based on their parent directory's context, with a few exceptions, which I'll talk about in a minute. RPMs can and in fact should be built with SELinux context information in them so that it can set the context of binaries and things like that. Even the login process sets your default context when you log into an SELinux system. Now, by default in a targeted system, you're going to run unconfined. Now, I talked a little bit about some exceptions. File transitions will generally create exceptions. If an application that has the fictional foo type label creates a file in a directory labeled bar type, there can be a policy, a transition policy that says when a file is created in those circumstances, it's going to take on a third type, BAS type, for instance. And a great example of this is the DHCP process, the DHCP client process. So if I get a new IP address, and when I get that new IP address, the DHCP server passes me information about the DNS server for my network, DH client will create a resolve.conf file, and even though it should inherit the etc type label from the parent, that file transition says that it will create the file with the netconf type in etc. So if you do an ls-z against your resolve.conf file, it does have the correct label because of that file transition. And you saw me use the SEmanage command earlier to take a look at all the settings for SELinux ports. You can use SEmanage to label SELinux logins, users, ports, interfaces, modules, nodes, file contexts, booleans, permissive state, and set don't audit. So you can do a ton of things with SELinux, but we're going to talk about the basics for the rest of this. So, errors. What does it mean when I get an SELinux error? I mean, other than the fact that it stops what I'm trying to do from happening, which is admittedly can be kind of a pain, but what does it mean? Well, it means that something is wrong, and depending on what it is that's wrong, we need to take different actions. But let me be very clear. Disabling SELinux because it's throwing an error at you is like turning up the radio real loud in your car when it's making a noise. No, clearly I don't have a problem. There's nothing wrong here. So listen to it. It could mean something very simple, that the labels are wrong. And that's probably the most common case, is something got mislabeled. And I'll show you how to use the tools to fix the labels. It could mean that the policy needs to be tweaked, and that's also really common. There are a number of ways that we can fix that. We can set a Boolean, or we can create a policy module, and I'll show you how to do those in just a second. There could be a bug in the policy. It happens. If you do think that there is an actual bug in the policy, please open a trouble ticket with Red Hat. Don't just file a Bugzilla report, because there's no service level agreement around those. There's no time guarantee. So file a ticket with Red Hat support, and we'll figure out what that is. Or fourth case is you've been broken into or are being broken into. In which case, man the battle stations, figure out what's going on, and rectify it. So you heard me talking about Booleans. Booleans are really just on-off switches for different functions with security-enhanced Linux. From simple stuff like, do we want to allow the FTP server or the web server to access people's home directories, to more esoteric stuff like, HTTPD can authenticate against Windows machines using modauth NTLM Winbind. There's all kinds of things that we have done our best to choose sane defaults. But as with everything else out there, the defaults are not going to be perfect for everybody. So we've given an opportunity, or given a mechanism whereby you can change those defaults. To see all of the Booleans, you can run get sebool-a, and there are hundreds of them. There are hundreds of settings that we that turn on or turn off SELinux capabilities. So, things like, can HTTPD talk to Spam Assassin? Can it access SendMail? This is a real common one. Can the web server access SendMail? In most cases, you probably wouldn't, but what if you've got some sort of web application that's generating emails? Obviously, you need to turn that on. So there are a ton of them, page after page after page after page after page of those Booleans. And I'll show you some examples of some of them in just a minute. So a couple of things that I've learned over the years from customers or just making mistakes myself is, in your development environment, make sure that you install SE Troubleshoot and SE Troubleshoot Server. Those will give you a whole bunch of extra tools that will allow you to get human-readable error messages from SELinux that are going to make your life a whole lot easier. And after you do the installation of the SE Troubleshoot and SE Troubleshoot Server RPMs, if you are a Unix admin, just restart the audit-d service. If you're a Windows admin, reboot. Sorry, I came from a Windows background, so I'm not being a jerk. I was just as bad. And what that looks like is you just install those packages. It's going to drag in about 80 megs worth of stuff, And when you get done and those are all installed, you can just do a system control restart audit D, or actually you'll get an error message if you do system control, and you have to pass it off to service audit D restart. That's actually not a bug, that's expected behavior. It freaked me out the first time I did it, but that is expected behavior. So let's talk about some real world-ish examples. So let's say you've got the user Fred, who has decided that he wants to have a home page in his home directory. So you being the good sysadmin, you go and enable userdir in the userdir.conf file. You restart the web service, and he creates his home directory /home/fred/public_HTML. And you know, if you've done this before, you know that you can go and turn on userdir by uncommenting that file, or that instance, or I'm sorry, that line in the file, restart the web service, change the permissions on his home directory so that the web server can access his home directory. So we do chmod o+x on /home/fred so that the Apache server can reach down into that public_HTML directory. Fred logs in, he creates his public HTML directory in an index.html file. So there's him making the directory, and there's him creating an index.html file. We fire up the trusty dusty web server, and permission denied. You don't have permission to access. So, being good sysadmins, we're going to check the usual suspects, right? I want to go look at var log messages. I want to go look at the HTTP logs, see what's going on there. So if I go and I look in var log httpd access.log, well, that's not very helpful. 403, well, yeah, permission denied. I already got that. So that doesn't help a whole lot. So I go look in error log, and again, it's really not that helpful. It just says cannot read the directory, which doesn't make sense because we know we set that permission correctly. So that's a little bit odd. So now we take a look at journal control, because system logs are handled through journal control. So I do a journal control -b-0 to show me everything that's happened since the last reboot. And this is kind of an eye chart, and I apologize, but I really wanted you to see what this looks like, because this is awesome if you've worked with SELinux in the past. This is really cool. It pops up in bright red letters in the log, and it says SELinux is preventing access to the index.html file. For complete SELinux messages, run this command, copy and paste. Tell me again that SELinux is too hard. All right? So, and then it also comes back and it gives you some really good information down here, including, it'll even say, I think that this is the command that you need to run. Based on all the times we've seen this error in the past and how we've diagnosed it, we actually proactively tell you in order what we think the most likely solutions are. So not only do we tell you, yes, there's a problem, but type this command to fix it. Journal control -b, yeah, -0. Yeah, journal control is kind of the replacement for tail-f var log messages. So you can do journal control or journal control -f. So anyway, so it tells us to run the command SEAlert blah, 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 and it reveals that there are several potential issues and suggests some solutions. So again, it comes back and it says, in order to access the home directories, just set this SE Boolean. If that's not it, you may do this. If that's not it, you may do this. And way down here, you know, so it's really pretty cool. Once you have those SELinux tools enabled, SELinux gives you human-readable feedback, including suggestions for what we think the problem is. So it's pretty cool stuff. It also says that we can create a policy module to allow this, but in this case, setting the Boolean is the right way to go. So we read what it says. It tells us that we need to create a policy module. I'm sorry, that we need to set a Boolean, and then, let's see, and it also, and it's kind of cool, it'll tell us that we need to set the context on a directory. So there's a bunch of things that it can do, but again, the first suggestion is just to change the Boolean. So we follow the instructions and we set the Boolean to allow the HTTPD process running with HTTPD_type to access the home directories. So set SEBool, HTTPD enable home dirs, 1 being the Boolean for on, and we pass it the -P argument to make that permanent. So you hit that button, and a couple of seconds later, boom, now we can access that directory. So the first time you run into SELinux issues, they can be kind of a pain because you look in the log files and you're like, there's nothing helpful here. But generally, if you use the tools that come with SELinux, they're very, very, very intuitive. And people tell me that SELinux is hard. I'm not buying it. It used to be. Now, can I see what Booleans have set? Let's say I'm a new sysadmin and I've inherited a system from somebody else. Yes, you can. You can look at the booleans.local file under etc SELinux targeted modules active. Now, I want to show you something. We've changed the home dirs directive. We've set the Boolean to 1 and made it permanent. But you'll notice that it says this file is auto-generated. Do not edit it directly. It's very serious about that. When you use set sebool-p or a lot of other commands, what it actually does is it regenerates the entire directory. So even if you do make a change in that file, the next time you run an SELinux command, it's probably going to regenerate the directory and your file settings are going to be lost. It doesn't hurt anything if you edit the file. It's just going to ignore it and it's going to nuke it next time you do anything. So I did a cool little experiment to show this off. I created a file, just touch marker file. It's a 0-byte file. And then I did set sebool-p httpd enable home dirs equals 1. And then I said, show me everything under the SELinux directory that's newer than that marker file that I just created. And it literally rebuilt the entire contents of that directory. So if you make any changes in there, they will be lost and they won't, I mean, they're not config files, so it won't do you any good. So let's look at another real-world example. Let's say that we've got a fresh new system, so ignore the previous one with Fred. Now Wilma's at it. Wilma is a web content developer, and she has created content in her home directory, and she's put in a ticket and said, can you move this content over to the web server? And being the good sysadmin that you are, you move the content over. Now, I said she was a web developer. I didn't say she was a good web developer. Because all she's done is she's just created an index.html file saying this is our cool website. But she's got stuff in her home directory. You being the good sysadmin that you are, you move the stuff out of home Wilma content over to var www.html. And when you go to test it, though, yet again, So being the good sysadmin, oh, I moved instead of copied, right? So it must be an ownership issue. And I do an ls-l against it, and sure enough, it's owned by Wilma. Ha, that must be it. I'm a silly sysadmin, I made a mistake. So you chown it, and you see that the ownership is correct for the other files compared to the other files that are in there. But again, once you test, it's having none of it. And so, again, we can use journal control. And it'll tell you that you need to run SEAlert and tell you that it's having problems, or the HTTPD process is not able to access that index.html file. So we run that command, and oh, things get a little bit interesting. I run the command, and it tells me that it's not allowing HTTPD to access the index.html file. Well, hold on a second. There was a... Yeah, okay. So we do an ls-z, and again, we see now that the reason it's telling us that is not because of ownership, it's because when we moved that file, it kept the context of being something that's in a user's home directory. And by default, the Apache web server can't access something that's got the home directory label. So, because we moved instead of copied, it kept its original context, and we can run one of a couple of commands. First thing we need to know is what's the context supposed to be. And the easiest way to do that is take a look at a known good file, right? So if I do an ls-Z against var www.html, we'll see that that's supposed to be HTTPD system content type. Now, the long form for using the chcon, change context command, is chcon-u, and then the SELinux user, -r, the role, in this case object role, -t, HTTPD system underscore, or HTTP sys content type, with underscores between them, and then the file that we want to change, right? Now, invariably, when something like this is going on, what do you got? You got your manager breathing over your shoulder, right? You know, is it done yet? Is the web server fixed yet? Is it ready? Is it up yet? Do you want to type all of that stuff out with somebody leaning over your shoulder? I don't. I don't. So I'm lazy. I'll be the first one to admit it. I'm lazy. So the short form, because we don't care about user or role, it's not really relevant in a targeted environment, you can just do chcon-t, the type, and then the file that you want to fix. But I'm really lazy. I really don't want to type all that stuff out. So if I just want to reference a known good file, I can do chcon-reference something good, and then point it at the thing that's not working. So I love chcon-reference, but seriously, I'm lazy. I don't want to even have to remember that. So I can use the restorecon command. Restorecon is awesome. You use restoreCon. I like to do -v so I see what changes it's made, and then -r so it does it recursively. And I say restoreCon against that directory, and it goes and finds anything in the directory that's not labeled correctly, and it sets it back to the default label. So restoreCon is your friend. I do that, and sure enough, you see where it says, oh, okay, I changed it from user home to HTTP system content type, and sure enough, once I test it, it works. So you may ask, where did that context information come from? restoreCon relies on the contents of etc SELinux targeted contexts files, file_contexts. And actually several other files in that directory. But that's where it looks to see what the default context should be for files and directories. There are like 4,000 entries in that file, so you're not going to edit it by hand because not only, not only do you not really want to go in and monkey around with that, but when you get an update, it's going to replace that file. But this is what it looks like. So it'll tell you, all of the different directories and all of the files underneath that directory. It'll tell you what the default contexts are supposed to be. So it's pretty cool. And like I said, there are page after page. There's like 4,000 entries in there. So I like this file because I suck at regular expressions, and I'm going to show you how to use a regular expression in a little while. And I always come back to this file and just copy and paste from here because I forget. So this is a good place to cheat from. So let's look at another one. Let's say that somebody tells you to create a web directory someplace totally non-standard. We know better than Red Hat, so we're going to put our web server in /foo/bar. Well, okay then. And you're going to create a virtual website there. So you create the directory, you do make dir-p/foo/bar, and you look in foo, and bar sure does exist, and the permissions are set correctly, right? They're world executable. So you define the virtual website in the httpd.conf file. That's all good. We see it there. And then we create the index.html file in that directory. So this is the dummyhost.example.com web page. We create the file, and it's there, and the permissions are good. We restart the web server, so restart the HTTPD service. But when we test the page, well, now this is a little different. We're getting the default splash page for a Red Hat Enterprise Linux web server, but we are not seeing the index.html file. So what was the logging resource we were supposed to check? Journal control, very good. So we look at journal control, and whoa, this one gets a little bit more of a mind bender, right? Because it does say, hey, SELinux is preventing blah blah blah. What you need to do is you need to change the file context on foobar index.html, and all you have to do is figure out which of all of those is the appropriate context. Yeah, it's obviously intuitive at this point. Right? College professor, everyone had that prof, right? They're writing with one hand and erasing with the next. Yeah. But no, I mean, and then the funny thing is, after all of that, it says, oh yeah, and by the way, use restoreCon. So down here at the bottom, once you've figured all of this nightmare out, figure this out. Well, you know what? This is actually not really as bad as you would think. We know that this is going to be web content, right? Where on the file system already has the correct label for web content? var www, right? So I can just take a look at var www HTML, and sure enough, it's HTTP system content type. And now the thing is, we want to make sure that foo and everything under it has the right context. So we're going to use a regular expression. And like I said, I don't write scripts enough anymore these days to remember regex very well. I was never a very good programmer. I'm more of a systems guy. So I cheat. I totally cheat. I'm lazy and I cheat. I'm a hell of a role model up here for you guys, aren't I? So I just go and I take a look in that file and I find the right regular expression. And so what I do is I use SEManage. SEManage tells SELinux about what you're going to do. It doesn't make any changes to the file system, and that's really important to remember. So I do SEManage. I'm going to set the file context, and I'm going to add type HTTP system content type to foo and everything underneath it. That's what that regular expression says. Okay? All we're doing is we're telling SELinux, hey, if you do anything with this file system, that's the default context for it, right? We haven't made any changes. So we do that, or if you're like me and you're lazy, you can just go, hey, SEManage, set the file context, add the existing directory to foo, and it'll take care of that for you. But once you do that, then you can run restoreCon against it, and it'll change the context of everything underneath it. So I do SEManage fcontext, make it equivalent to var www HTML on foo. I run restoreCon, and you can see that all of those get set to HTTP system content type. Did you have a question? So yes, you could. Yes, well, no, it would survive a reboot, but what if you relabeled your file system? So the question was, couldn't we just use chcon ---- reference? And the answer is yes, until somebody relabels it. If somebody relabels it, it's going to set it back to who knows what, because it's not in the, it hadn't, SELinux doesn't know about that directory structure. So, but what I generally recommend is tell SELinux what it's supposed to be using semanagef context, and then set it to what it's supposed to be using restorecon. Does that make sense? We tell SELinux about it, and then we fix the file system. All right, so now we test the site. Sure enough, everything comes up. dummyhost.example.com works, and we're in good shape. Now, policy modules are sort of the next step of SELinux. If setting a Boolean or just changing a file context or restoring the context on the file system doesn't work, you may have to create a policy module. And it's not really a big deal. Now, this is an older example, and one of the members of the community was actually giving me a hard time about this, because he's like, man, you're still using a Rel 6 example? I have tried to find a good example for something that doesn't work on Rel 7, and SELinux has gotten good enough and the policy is complete enough that I can't find a good example like squirrel mail was on Rel 6. I'm going to bug you actually later and see if I can come up with a better example of this. But this is a great example of the steps that are involved in getting SELinux to work with an application that it doesn't know about. So in this case, I've installed SELinux on my Rel 6 machine. I go to log in and it barfs all over the place. Nope, sorry, you're not allowed to connect to IMAP. It'll throw errors. Now, in the early days, back in the Rel 4 time frame, this is what the errors looked like. So my first instinct was to go look at var log audit, audit.log, and that is just, I'm sorry, it's just awful to read. It's not very human readable unless you're living and breathing this stuff all the time. So then instead I go and I take a look at var log messages, and again it's the same thing. It says, hey, to figure out what's going on, run this command, copy and paste this command. So I copy and paste it, it tells me what's going on, but here's the thing. I can go fix one problem at a time, but if I leave SELinux enabled, I'm going to fix a problem and expose the next problem, and then fix that problem and expose the next problem. So it can be very time consuming. So that's what we set SELinux permissive for. So we can go set SELinux permissive, run the application through all of its paces, and you're going to get a whole bunch of SELinux errors, but because it's in permissive mode, it'll only log the errors but not actually prevent the application from working. So set and force 0, run the application through all of its paces. Doesn't matter if it's squirrel mail or a database or whatever you're using in your environment. So I send email, I log back in as another user, I receive email, I respond back to the email. So the system is working, it's sending and receiving and authenticating users, and everything's good. So I can go and take a look at those error messages that I got from from varlog messages or from on Rel 7 machines journal control. And the cool thing is, it'll tell you, hey, if you want to fix this, grep httpd from that audit log and then run it through the command audit to allow. Give it a name of a policy file and go from there. So I do that. I grep httpd from audit.log. I save it as squirrel local. Now me personally, I label my SELinux policies with the word local in them just so I know that it's something that I did and it's not one that came with the system. Then I do semodule-i to install, and now I could have fixed this with a Boolean. But I wanted to show you creating a policy module so that you could see it done. If I look at the output of that audit to allow file, you'll see that basically what it's doing is it's telling SELinux to allow HTTPD access to the SMTP port using name connect. So it's just saying that yes, you can send email from the web server. So once I do that, I do the semodule-i squirrellocal.pp, turn SELinux back on, and I log in and I test everything, and sure enough, I can send and receive mail and everything's working just fine. So that's how hard it is to fix SELinux if you need to create a policy module. grep pipe audit to allow. Sorry, grep pipe audit to allow. So not nearly as hard as you might think. Now, how do I enable SELinux in a system that that has it turned off? So you want to check the etc SELinux config file, set SELinux to permissive. Don't set it to enforcing and then reboot. You're going to have a bad day. There's going to be a bunch of the file system that's not labeled and it's going to hang. So I change it to permissive. I reboot the machine after I create a file in the root of the file system called .autorelabel. When I do that, I create that file and I reboot, it's going to come up and you're going to see a bar creeping across the bottom. It'll take roughly the same amount of time as it takes to do a file system check because it's relabeling everything. You can also run the command fix files relabel, but don't do that in run level 5 because it nukes everything in the temp directory, including your X font stuff. X window tends to get really cranky when you kick the fonts directory out from underneath it. It's funny how that works. And then you reboot after it's done. So that's what that looks like. Fix files relabeled. After everything's relabeled, then you can set it to enforcing or just type set enforce 1. So everything that we've done has been from the command line. But there are even graphical tools to do this. So I can even teach a Windows admin to do this. Install Xorg X11X off, a font, any font that you like. I like bitmap fix fonts, and Policy Core Utils GUI. You can SSH into the box and run system config SELinux. So you yum install all that stuff, it'll get installed. Then you SSH into the machine with -Y, so you can do X forwarding. Run system config SELinux, and everything that I've talked about so far is available graphically. What's my default mode? What's my current mode? What's my policy? Targeted or strict? I'm sorry, targeted or MLS, permissive or enforcing. Do I want to relabel on the next reboot? When you press that button, you know what it does? Touches .autorelabel and sets the machine up to reboot. I mean, it's super simple. I can look at all my Booleans. I can look at file labeling, including I can drill down to that foo directory that we created so we can see our custom content there. I can look at network ports. You remember when I looked at the HTTP port type, we saw that it was on 80. Well, there's 80 and 8088 and 8443, all those things that we saw from the command line, they're available through the GUI. I can even look at my policy modules, including that squirrel local module that I created. So hopefully, after all this, we feel like we're the Charles Atlas we've been working at home, and that SELinux bully isn't going to be nearly as much of a problem anymore. Final thoughts, don't turn it off. I know it's easy. I know it's easy to say, oh, SELinux sucks, I'm going to turn it off, but really don't turn it off. This is a pretty amazing technology. I have seen customers, and I have personally had cases where systems got compromised and SELinux stopped them from doing things. And I've also seen organizations show up on the front page of the Wall Street Journal who have had SELinux turned off, and had they had it turned on, they wouldn't have been on the front page of the Wall Street Journal. Raise your hand if you want to be the guy explaining to your CIO why your company is on the front page of the Wall Street Journal for being hacked. No volunteers? Dang it, we're not going to get to laugh at anyone today. Y'all are making it easy. And it's so much easier today to work with SELinux than it was even a few years ago. So, you know, really, it's NSA-developed security. It's badass technology. It's included in the operating system. It's not like you have to jump through any hoops. It's even enabled by default. So, really, use it. Was this helpful? Was it good? All right, good, excellent. If it was helpful, please give me a good rating. It's really important that I come back next year to have a good rating. So if this is helpful, let your friends know. Give me a good rating. If you didn't like it, just keep your opinion to yourself. There's additional information available at the SELinux guide, the Fedora Project SELinux doc. You can subscribe to the Fedora SELinux mailing list. It's super, super helpful. And it's not real high volume. I'm subscribed to it, and I get really good information from it. And I generally stay quiet because I don't want to bug the developers who are on there doing the real work. Access.redhat.com has a ton of videos about SELinux. Dave X and Dan Walsh have done some really, really cool topics. And you can always check out Dan Walsh's blog. Dan is sort of the master of all things SELinux at Red Hat. And with that, thank you very much. Thank you for coming, and I appreciate it.